pretty sure I said at the beginning of the first video that these videos are going to be short. The first two were definitely not short. I'll make it up to you with these two. Part 3 is finite differences. What's a finite difference? Well, it's a difference found from looking at the y values in a table when we have evenly spaced x values. So that means our x values are going up by the same amount. And then we're going to look at the difference in the y values. That's called a difference. The first difference is when you're looking at consecutive y values, and the second difference is when you're looking at consecutive first differences. And I'm going to show you what I mean. We're going to look at two equations here. One of them is linear and one of them is quadratic. How do I know? Well, linear because it's y equals mx plus b. There's no x squared term. Quadratic because we have an x squared term. There could be x terms and constant terms, but this parabola does not have those extra terms. So we're going to make a table. Sorry, I guess I should say, this being the biggest exponent makes it linear, and this squared term makes it quadratic. So let's come up with some y values. We're going to use our x values. So we'll do some math here. 2 times negative 2 is negative 4, minus 5 is negative 9. 2 times negative 1 is negative 2, minus 5 is negative 7. 0 times 2 is 0, minus 5 is minus 5. And the thing about linear is it's just going to keep following this pattern. It's going to keep going up by 3. So we got up by 2. So we got negative 3 and negative 1. So first difference. Well, what's a first difference? First difference is what's happening to our y's. And I kind of spoiled it by saying they're going up by 2. And they are going up by 2. Negative 9 to negative 7 is up 2 because it's to the right on the number line by 2. What math can I do to show that? Well, you can do the y2 minus y1 math. You can take the second y, negative 7, and you can subtract the first y. Negative 7 subtract negative 9 is like negative 7 plus 9 gives us plus 2. And if we keep following that, the next one would be negative 5 subtract negative 7. We're going up 2 again. And in fact, we're always going up by 2. Notice these first differences are the same. And that's because our graph, our line, is constantly going up by the same amount. That's the slope. It's constantly going up by 2. Quadratics don't quite behave the same way. They don't go up by the same amount each time. Let's do the math to prove it. Negative 2 squared is 4 times 2 is 8. We actually made this table on the last page. Negative 1 squared is 1 times 2 is 2. 0 squared is 0, so that's going to be 0. Now we're going to be symmetrical. 1 squared is 1 times 2 is 2. 2 squared is 4 times 2 is 8. Now we have our y values. So what's happening here? Well, let's look. From 8 to 2. Well, that's going down because the number's getting smaller. It's going down by 6. And you can figure that out by doing 2 minus 8. 0 subtract 2 would be minus 2. 2 subtract 0 would be 2. And 8 subtract 2 would be 6. Notice this time the first differences are not constant. Second differences describe the change in the first differences. So what's happening to the first difference? Well, negative 6 to negative 2 is going up, so we're going up by, well, how much? Negative 6 to negative 2 would be up by 4. And to get that, we could do negative 2 subtract negative 6. That would be positive 4. From negative 2 to positive 2 would be up 4 again. And from 2 to 6, again is up 4. This time we have the second differences are constant. And this is going to become trademark. If you have something that's linear, the first differences are always going to be constant. And if you have something that's quadratic, the second differences are going to be constant. And to tell what difference is going to be constant, this is a little bit of a spoiler for something that's going to happen in grade 12. You're really just looking at the biggest exponent The exponent's 2, so the second difference is constant. In this one, the exponent's 1 on the x, so the first difference is constant. What if there's an x squared term and an x term in the same equation? Well, you look at the biggest exponent. There's 2 more tables. I want you to complete those tables and see if you can show for the first one, since it's a line, the first differences are going to be the same. And for this one, since it's a quadratic, because it's got an x squared term, the second differences should be the same. If you can demonstrate that, you understand finite differences. Our conclusions down here on the bottom. What do you notice about linear relations? All you need to notice is that the first differences are constant. I kind of already said it and highlighted it, but for completeness, let's fill it in. And for quadratic relations, it said nonlinear, I want it to be quadratic. These second differences are constant. And there we have it. That's finite differences. Please try to show the first and second differences being constant. And if you run into a problem, just check the solutions on the course website to see where you made a mistake. And thanks for watching part 3. I'll see you for the last lesson of 4.1/2, part 4, where we look at applications.